Well, welcome, especially welcome to the students of the CIEE. Students of the CIEE, there. Thank you very much to have this confidence in our institute. Welcome, especially you. Welcome evidently to the students of Genova, but yesterday I had the occasion to say you the same. Welcome. Evidently, welcome to our students also today, and welcome to the people who is here with us. And I want especially to say to the students of United States, CIEE, that you are in a very good space, I think. You have a fantastic program. Javier Peña and Antonio San Martin are, and I say, one of the best architects, not teachers all, not because teachers is good, but they are practically some of the best architects in Spain, because Antonio is more Catalan and Javier is from Murcia, but they are fantastic architects and very innovative. The program, I think, is very good, and the idea is to have this weekend an exchange with the students of the IAAC, the students of Genova that are here, and to have a good moment of productions together. I say the same for the students of Genova, my students there. In fact, the idea is this, no? Now we have the first occasion to have a mixed situation of different students, and with different methodologies, some things with different feelings. And the idea is these days, for you, this time, to have occasion to talk, to speak. The IAAC was this, a space of exchange, a space of freedom, a space of experimentation, also a space of, how to say, of enjoying research, not to suffer research, not to be, and to be afraid to be in a school, in a big center, to have, this is a laboratory, and the idea is this. Evidently for our students, this is clear. We have students of very cosmopolitan, a cosmopolitan space of all the world, but with you, this is more rich, it's more important. You have a density now of people, and we are very, very happy to have this experience. Thank you, Maria, for your confidence in this experience. I'm very glad to have Maria with me, because I think you are a motor of things, and also you have the capacity to be an inductor and also a stimulator. It's not the same exactly, no? And this is very good. And thank you. And just this, I hope that this experience is a little experiment for us. It's not because it's a hosting, but a hosting it's not, how to explain, it's not a hosting, it's a program. It's a program inside of another program. It's a kind of pilot thing where it will be very, very interesting. And the only thing that I hope is to have more interaction between people, between students. Also, why not? The curiosity to have our faculty, the faculty of the different faculties, moment of exchange and also curiosity. And with this I finish. I introduce, well, Luis, for the students of Genova, and for the Luis Fraguada is our Director of International Programs. And Luis is going to introduce Maria better. I give the floor, the stage to Luis Fraguada, our Director of International Programs, and also for the people of Genova. When you know some things of summer school, this is one of the responsibles, and thank you. And Luis, I give you the stage. Thank you very much.
Okay. Well, yes, to be brief, I think Manuel has summed it up pretty well. I am very glad to introduce you to Maria Aiolova, and not just, well, because there's many things here on this piece of paper which I will read and let you know about, but also because it's not often that we find people that are very, very so aligned with what we're trying to do here at IAAC, and I'm just happy that finally our our two sort of, I don't know, institutes or whatever you want to call them are joining together. Maria Aiolova is an educator, architect, and urban designer in New York City. Her work is focused on theory, science, and application of ecological design. She's a co-founder of Terreform ONE. In 2013, Maria was appointed academic director and global architecture and design of the Council on International Educational Exchange. Presently, Maria chairs the One Lab New York School for Design and Science and the One Prize Design and Science Award. She is an institutional advisor to New Lab at the Brooklyn Navy Yard. She won the 2013 AIA New York Award for Urban Design. Maria is currently a visiting faculty at the University of Applied Arts, Vienna. Most recently, she taught at Pratt Institute and Parsons, the New School for Design. Formerly, she served as Vice President and Chief Scientific Officer of ETEX Corporation, a biotech company in Cambridge, Massachusetts. Maria is an inventor who holds 18 technology patents. She was the winner of the Victor J. Papanek Social Design Award and the Museum of Arts and Design in 2011. Maria has won a number of design competitions, including first place in the Charles MGH Station in Boston and the Izmir Post-District International Competition in Turkey. She also won the Zumtobel Group Award for Sustainability and Humanity and the Build Boston Award. So with that, I give you the floor, Maria. Thank you very much.
Okay. Well, thank you so much for the introduction and for having me here. And I'm really happy that today it's the inaugural day of our new program here at IAAC. So tonight I would like to tell you a little bit about Terreform ONE. We are a non-profit design group in Brooklyn, New York, where we spend a lot of time thinking about the future of cities. And we decided that in order to assure the future of cities, we need to start a new profession. And we call this profession urbaneers. So the urbaneers are these multidisciplinary professionals, and their role is to regenerate, pioneer, and sustain the future of urban Rome. And here, it's kind of an idea. Instead of fixing a Ferrari, we have all these different professionals working on Manhattan. And almost any mixture of discipline can work. And often I'm asked the question, who is the perfect urbaneer? And here's kind of a story we tell. If you imagine that Jane Jacobs and Robert Moses had a child. Very unlikely, because these two are arch enemies, but history has known worse marriages. And so this child would possess kind of the sense of community that Jane Jacob had, and then the sense of magnitude and achievement of Robert Moses. And that child, even though not historically correct, will be somebody like Frederick Law Olmsted. And that's our perfect urbaneer. So, you know, this is a very complicated chart laying out all these different professions that we want to combine. But the truth is that it happens in the middle. So it's somewhere in between, kind of overlaying all these different skills and knowledge, where you will discover what you want to be and forge your own path. And that's what we're trying to teach, and we'll be experimenting right here at IAAC with our students. So. This is Kevin Pratt, it's a friend of ours, who said that about our work. And I believe that's what we do, and we continue to do so. Because you cannot get anywhere in life if you don't imagine it first. So in order to train these future urbaneers, we had to start a new school. And that school is called One Lab. We've been running it for 6 years now in Brooklyn, New York, and every summer we have a group of future urbaneers that come and experiment with us, and it's really hands-on, and you learn everything from computations to principle of synthetic biology. And here is Dr. Oliver Medvedik, who is a biologist, teaching with us how to sequence DNA, learning physical computation, vacuum forming. to grow building blocks out of mushrooms, planting trees and bleaching them together to make an actual living wall that is structurally stable. And finally, learning the principles of phytoremediation, of cleaning water using plants. Here, our students constructed these units that can use also black and gray water, and just the root structures of the plants can clean it and convert it back to drinking water. So where we are today, as I said, we started in 2009, we've been teaching in New York, and we had this dream to grow the school first in Europe and then around the world. So, whoops, that didn't look very good. I don't know what happened. Anyway, well, we entered a partnership with CIEE, and this week we are starting 3 new programs here in Barcelona, and Berlin, and Prague. And so we have, the students have arrived, and we're going to experiment what we've done in New York to take it here and see if we can apply the same principles and learn from Barcelona, bringing our students and using the great institution of IAAC, but also the thought leaders who are here in Barcelona to build this new program. And in New York, where we are the place called New Lab, and that's the Brooklyn Navy Yard. For those of you who don't know New York, this is Manhattan over there, this is East River. The Brooklyn Navy Yard is 300 acres of this industrial facility where they used to build big ships, big battleships, and it lay vacant for many years, and now we are converting this big old factory into New Lab. This is where they used to build turbine for these ships, and now we are building these collaborative design and fabrication facilities. The idea is to combine both students. Our school will be there together with Columbia University, Rensselaer Polytech, several other schools, with innovative firms, thinkers, all under one roof, living, working together, one place. And the idea is that innovation doesn't happen in isolation. It happens by this, what we call it, serendipitous interaction. And then it's very similar to IAAC here in the space that you're seeing and experiencing here, that when you're surrounded by these people doing all these interesting things, there is this charge in the air that it's some kind of, it can transfer things to you. So that's what we are trying to create. We decided not to wait. And obviously the public aspects of lectures and talks will be there. But we decided not to wait, and we started what we call the beta space. So these are the 2 developers. This is an interesting project because it's a public-private partnership. The building is owned by the city, but they gave it to us, and these are private developers that are putting their money to build this amazing space. And this is in my studio today. We have several sponsors, including EOS, which is the most advanced 3D printing machine. This machine that we have can print anything from rubber all the way to metal. So it's not about prototyping anymore. You can actually print final objects, and we are starting to experiment with it and working on our new project. And then just very quickly, I wanted to show you kind of the group of people that are there. And a lot of them were trained as architects, but chose to kind of forge their own path. These are the co-founders of ecosystems that developed kind of a new type of modular furniture using reclaimed wood. Jessica Banks of Rock Paper Robot, she designs kinetic furniture. This is a chandelier that it's triggered by ambient noise and can subtract or expand and put light in different spots in the room. Ed Jacobs, who is an industrial designer, among other things, he designed the solar collector for the low line. You know, in New York we have the High Line Park, and now we are developing a new park in an abandoned subway station. So at Jacobs, he was able to have a system that you can bring sunlight from the street to underground and support photosynthesis. This was a test exhibit that you know, all this was tested, and currently there is a new nonprofit that was formed. They're fundraising. They want to build this new park that is going to be completely underground. So fiber optics, and it's already kind of proved that this can work. Marcel Bora, another architect, graduate of MIT Media Lab, turned serial entrepreneur. He invented a new baby spoon. So this is designed and manufactured at the Brooklyn Navy Yard. It's apparently the first ergonomic baby spoon that the babies can latch on it the way they latch on the mother's nipple. So a better way to eat. Jana Spivak, she's an artist who works with living matter, and she invented this very low-tech micro farm. And she wants to prove that you can turn any piece of furniture into a small farm, and you can grow a salad every night. So here is my partner Mitch and I working on a future city, I guess. And so from there, I wanted to show you some of the projects under so-called urbaneering movement. And this is, I put these projects together because we'll be working here on the idea of cities and water, and this is East River in New York City, and two sites. We're talking about downtown Brooklyn first. And then again, this is a long-term research project that a lot of our students work on it. The idea is that we took a portion of Brooklyn and we said, can this place be completely self-sufficient with its boundaries? What we wanted to achieve is to have a place that can produce all its food, energy, water, work. The only thing that goes in and out is culture. And we always start with research about where we are today. No recycled water. 6% renewable energy is actually really good for the US. New York is leading that pack. And we looked where it first started. In 1776, when it was first settled, what we called productive green space, it was space that was used for agriculture, what was used for pasture, and also when you see the yellow there, it's marsh and wetlands using to purify water. Where we are today, we have zero productive green space. There are a few parks. The Brooklyn Bridge Park, it's pretty nice, but the rest of it kind of parks that are walled off around housing projects that are not really used. What we would like to do is go back to where it first started. Reclaim this productive green space, use it to produce energy, use it to filter water, use it to produce food. And in order to do that, we said we'll actually reverse the figure ground. And remember, we're projecting 100 years from now. So we said we did an inventory of all the existing buildings. And in downtown Brooklyn, really, there are only a few buildings that are worth saving. So if we combine all the program into kind of a very dense artery, we can achieve this. And this is now the ground plan of Brooklyn 100 years from now, where we actually removed the BQE, which is the expressway that Robert Moses put in place, and it's dividing the neighborhood, and put a canal right underneath it. So by combining program in these very dense arteries, where we combine both commerce, housing, soft transportation, all in one single structure, we can free the rest of the space to be productive. Mr. Moto, that travels around the world. It's currently in Toronto, of what is the future downtown Brooklyn it will look like. And then, so this is 100 years from now. We focus in another area down the river. This is Governor's Island in Red Hook. And we wanted to look in more near future. What you see here is the evacuation map that was created during Hurricane Sandy. All these areas that are in a dark blue were actually underwater. So the idea was, how can we protect this area for future floodings? And here it's kind of our idea of to create these new lands and barriers to stop the water from flooding this neighborhood. Red Hook is one of the poorest neighborhoods in New York City and was really affected. And we started with, I know you cannot see all this data, but this is research about restoration and reclamation techniques, and we evaluated all of them, and we figured out that gabion walls are one of the most effective way to achieve what we set to do. However, they're quite expensive because they require a huge amount of materials to be constructed. So we did some research and we found out that there are all these, what they're called ghost fleets of former military ships that have been retired. Shipwrecking, it's a big industry. I mean, US, we sell old ships to countries as far as India and China. Military ships, however, we cannot send abroad. They have to stay in the US. It's considered, part of the heritage. So there are thousands upon thousands of these ships that are retired, they're not used. We decided, what if we cut them into sections, and we can submerge these sections around the island and use them as these barriers to build wetlands, and these are constructed wetlands. So here are some of the diagrams of how this can happen. They're about 40 feet in depth, and that's kind of what we needed. And you can actually do this. And we did a study with some simulation techniques of how this was going to work. And over time, the sedimentation will happen. And here are some of the renderings of how this will slowly start to build up. What it may look like. And then and this is a model that we built, always big models, a lot of fabrication techniques. And then finally, if we project 100 years from now, when it's kind of fully built and fully filled, this is what the new park may look like in what we call the Governor's Hook now, combining Red Hook to Governor's Island. Some of the details of this park, this is the idea again of combining recreation with productive green space. These are robotic algae farms that can produce energy in a public park. And then finally, the idea of new kinds of transportation. This is what we call the blimp bumper buses. This idea was born watching, I don't know if you've seen the Macy's Thanksgiving Day Parade, where it takes 50 people to hold down like Superman and SpongeBob. And we figured out, what if we harness this energy and use it as transportation? So you can kind of have lift chairs, and you can hop on and off. They kind of float about water and also above the avenues. And finally, combining all these different ideas, and I'm not going to talk about soft cars, but it's something we've been working on for many years. But the idea is, what if everything has a modicum of intelligence? So all these different modes of transportation, including the street, can talk to each other and exchange the information. And then nobody has to die again in a car accident, because we can rearrange the street in a dime. And if a small girl drops a ball on the street, we'll put a barrier there and stop the traffic, so it will never happen again. So, moving on, rapid refuse, it's the idea of using waste as resource. The idea came actually before Disney created WALL-E. It's one of the most affable robots, building this ziggurat out of waste. And a lot of our work has to do with kind of visualizing ecological thought, because we know we produce a lot of waste. I mean, we asked the question, how much waste do we produce in New York City? Well, we make 36,000 tons every day. It's a lot, but how much is this? Well, we start making models. So this is just 1 hour piled around the Statue of Liberty for scale. So you start to get the idea that it's a lot. And then we've looked at what is out there in terms of available technologies used today to compact waste. And there are these machines that we can buy off the shelf. And then we decided, what if we have these jaws and that we modify them to have this puzzle-fitted geometry to create building blocks, separating organic from plastic from metal. We can use the organic waste with another technology that we are developing, and I'll show you later, a mycelium, to make actually an insulation material. Can you guys hear me?
The gentleman, the people back there want to hear you.
Should I move it? Oops. How's that now? Can you hear me?
In the back?
In the back. Yes? Okay. So the idea is that we can separate this material, compact it together, and make some kind of a new building block out of waste. Incorporate this technology in the actual construction, and here is what we call the 24 hours tower. So now this is 36,000 tons of waste. If we convert them using this technology, we can build a 54-story tower every 24 hours. I know we will probably won't build such a big building, but this is just to drive to kind of set the polemics, and we continue to research to prove that it's possible actually on smaller scales. But the idea here is that we can convert waste to resource. So there is no point in the future we have to have these mountains of waste anymore. We can use them to build new cities. And then, as I said, visualizing ecological thought, it's an important part of our work. So here are some of the sculptures that we have been making using waste. Here in Darmstadt, working with the university, we did a 2-day workshop where we took all the styrofoam from 1 week of delivery, and we built these robots that we put all around the city. They were very popular, and they had sensors, and you can scan them and find out, where the waste came from. And then we made a big star out of styrofoam. This is at the Metropolitan Museum of Art. It's a concert by Paul Miller, also known as DJ Spooky, and we made the sculpture out of waste. This is about 30 seconds in my neighborhood. I had some volunteers who brought it to us, and it was really interesting. We had to deliver it to the museum through the Egyptian wing. So we moved this star made out of waste right next to all the mummies, and so they wouldn't let us take any pictures, so I cannot show you that. And here it is, and then we put it at this Festival for New Ideas for the Future City, organized by the New Museum in New York. It's next to the Big Bubble by Ram Labor. You've seen it, that storefront for an architecture put up there. And again, scan it, you get the information. The children really liked it. In fact, we couldn't keep them away. This is what happened at the end of the day. They actually attacked the sculpture, and the security had left at that point, so I was done. So we hope they learned some lesson here. From there, this project, everybody calls it the meat house, but it's actually the in vitro meat habitat. We work a lot with biologists. This is the first biolab that we built, now 6 years ago. We had a budget to buy a 3D printer, and they were very expensive at that time, and we decided that we actually can purchase some stuff on eBay and then build a biolab. And looking again at technology that exists for many years in regenerative medicine, and you can print living cells, and you can grow a bladder, And so we decided, can we make a whole house out of meat using kind of a similar idea of some geometry. And this is kind of the thinking about what the meat tectonics will look like, the section, comparing it to a typical stud section where we're replacing, like the bone can be, the structure, and the fat is the insulation and the skin, and then the sphincter cavity is used as the window. And then some of the first renderings, and again, we can make it look like neo-colonial or Georgian style, but we thought that will probably look very ugly. So this is the model of what the meat house can look like, and this is not alive. We had to kill it, and it doesn't have immune system, so you cannot keep it alive. But the idea is that this is possible. It's very expensive today, but we proved that we actually can grow meat tectonics to build a whole dwelling. And then, of course, this was a scale model. Here we had a show in Prague, and we put the meat house in front of the cathedral so you can face God or religion. But again, this is the polemic. The real research continues here, so we know we are not going to grow a whole house out of meat, but the idea is, what can we do? And what if we can have kind of a living wristwatch that it's grown, and somehow it's connected to kind of and it measures other things, not just time. So we're looking into it, and we actually built, this is a custom built 3D printer that can print living cells, and we're currently experimenting with that to see what are the applications of this technology. Microfoam, it's another idea of collaborating with biologists, and it's the idea of growing building materials out of mushrooms, or the root structure of mushrooms. And here is now, I talked about the polemics of how much waste we make, but we actually continued to develop this technology to prove that we can make this brick out of waste. And so this is about the size of a building block. The outer shell is made out of compressed metal, and in the middle we are digesting organic waste with spores from mycelium and growing this material. So it's a very simple process. You start with mycelium in a petri dish, you provide substrate, temperature, and water, and the outer shell, it's just pressed in a hydraulic press. So we have currently a grant that we've written. We're hoping to start this in Sao Paulo, in Brazil. So you can set up a small shop with a micro grant of about $500 and make these bricks and probably build just small dwellings out of them. So this is the mycelium propagation. It happens very fast, in 8 days. Ecovatives is a sponsor and a collaborator in this project, and they've been growing mycelium for years now, replacing actually styrofoam and other materials with it. And then this is how it looks like, and then this is, we believe it's the future of materials, that we are going to be able to grow them from a few microorganisms that are naturally occurring and therefore free. And from growing a building block, we decided to see if we can actually grow furniture using the mycelium as the structure. And we developed, again, with a group of biologists, this new analogous leather material from another bacteria called Acetobacter. And so this is now combining mycelium and Acetobacter and this is a baby seed. And this is some of the first tests. The Acetobacter is bacteria that is again occurring in nature. It's used in some of the health drinks like kombucha. If you bought it in a health store. It's the same bacteria. If you grow it in a vat, you can make this material. And here the invention is that we are cross-linking it with chitin, which is the material that your fingernails are made of. And that makes it waterproof, and therefore analogous to leather. So this is the design of the Gen 2 seed, and kind of we took the inspiration from the seed bone. And here is, this is, as I said, it's a baby seed, and this is little Mia Joachim, my partner's daughter, sitting at it. And then the idea is when she grows up, we'll actually be able to do that. We'll be able to have these seeds that, you can use them, and then when you're done with them, you just take it and bury it in your backyard, because, and it will continue to feed other microorganisms, not just like an IKEA chair that will end in a landfill. And then this is the final project that we are currently still working on, and the question how to make the world work for 11 billion people. I'm sure you've all seen the projections of where we're going to be by the end of this century. And the question is, where are these people going to live? This is a map of population density, and one interesting fact that more people will live actually inside this circle than outside of it. So we decided to start this project by kind of mapping and calculating density, and then using the Buckminster-Fuller Dymaxion projection, where he 70 years ago unfolded the Earth in this new way, showing that all the landmass is actually interconnected. And that allows for flow of both population but energy. And so if you imagine, these are the hot spots that we discover. All the red, it's where these super density cities are going to occur. And his idea was looking at this Dymaxion projection. What if we actually interconnect the whole world into one single energy grid? And that can allow for energy to flow from daytime to nighttime hemisphere and bring it to all these spots of really high population density. These are some of the details of the study. So our goal was to visualize this idea, and it's kind of a two-sided map. On one side, we did this kind of parametric design of extracting the density and showing where actually the population is going to grow. And this is the whole map. The black spots are where the population is shrinking. And these are, the future urbaneers that we're training at One Lab, building it. This is how it looks. But the most interesting part happens actually on the other side, where we chose the 25 fast-growing areas, and we mapped them in a petri dish. So here we are using E. coli that is genetically modified to express color under fluorescent light, and we selected these areas, and this, for the first time, we are actually being able to spatially grow the different dilutions of E. coli. And this is kind of a new idea of parametric design, or it's bioparametric, using actually living matter to project where the population growth is going to happen. And here is the area of Istanbul. And here it's our projection of where the population density is going to happen in the next 100 years. And here is the whole wall with microscopes focusing on all these areas. It's currently in Rotterdam, the new institute there, and was just selected to be part of the Venice Architecture Biennale this summer, so it's going to be in Venice from June to November if you want to go and see it. And once again, why do we do that? Because we think this kind of way of thinking, of incorporating biology as technology and studying the population growth, we may arrive to some answers how to make the world work without causing damage or disadvantage to anyone. Thank you.
Well, this got turned up instead of her microphone. Thank you very much, Maria. Very interesting to see all the work in this context. Open it up to questions. Anybody have a question they'd like to pose to Maria? While you're thinking about that, I'm going to turn this microphone down. Questions from the front row? Maybe this general direction? Or from the front row? Okay.
What's the question?
You don't have to, but so that folks back there can hear you, it might be useful if it doesn't blow up again. Check, check.
You want to repeat it?
I can repeat it, sure.
I was going to ask, what's the biggest challenge in, since these ideas are all new and they need some grants, what's your biggest challenge in presenting or convincing people that are not from the field, either from architecture or biology? What's your biggest challenge in convincing people to grant money towards that?
Can people hear me here? Or,
They can hear you there, yes.
Can you hear me? Yeah? No?
There you go.
Okay. I'm going to repeat the question. What is the biggest challenge of convincing people that these new ideas are valid, especially people who are outside the field of either architecture or biology? Well, it is our goal to do that, and that's why I think the idea of, as I said, visualizing ecological thought, we strive to do that in a way that it's comprehensive to kind of larger audience. Our work is exhibited typically in museums and galleries around the world that are not just for architects, and we have, well, not ashamed to say, but kind of our lowest denominator. We always, think about it, will Bart Simpson get it? Can we make it that clear that he'll get it? And I think so. I mean, people draw different conclusions from when they see a meat house or a tower out of waste. Some laugh, some dismiss it, but I can tell you that everybody has a strong reaction to it, and we think that's important.
Over here. Very good.
It's a question, but first, thank you very much. I was very impressed. I knew some things, other not, and I was absolutely impressed. I think that is full of imagination and also conviction to do. This is very important, not only to imagine, but to decide to demonstrate some things. I was very impressed. For example, in the some things of reuse I didn't know, and they are very, very interesting. All the urban projects were more, perhaps for me, more new, but all this part of reuse was absolutely incredible. And this last project I didn't know, and in this last project I need to understand more, because I was very interested. This part of lifing reactions to understand the growth with living substance and the capacity to, how to explain, to not to react with datas and at the same time to living substance. No, this in the last project, because I think this is a new change of paradigms that it's very interesting. It's not only modeling, it's the capacity to have an interaction between data, suggestions, and something more intuitive, kind of curious space. And perhaps if you can say more about this last project, it will be very good. Thank you very much, and congratulations, to be sincere.
Okay, so this most recent work, it's still under development, but it's the idea is to take an actual living algorithm, because the algorithms that we use in computation, they are derived from nature, and they are kind of an idealized versions of nature than we use in computation. So we said, well, what if we go to actually biology and then try to see if we can study that using living bacteria. So it's a very carefully designed experiment where it's known fact that you can correlate the population growth to bacteria growth and use different dilutions. What we offered as something new, it's to do it spatially. So in each petri dish, by imposing the geopolitical constraints of boundaries of oceans, and then what we can manipulate is certain factors such as food and energy. So it's obviously it's similar to the way you do it in parametric design. You use certain parameters to construct your experiment. We did the same thing, but this time it's by using this living bacteria, and it's, as I said, it's genetically modified, so it expresses fluorescent light under long wave UV. So we were able to then to prove that you can, by manipulating factors such as the amount of food, the amount of energy, we can see certain amount of growth that appeared spatially. And we are still trying to analyze the data, but the kind of the point is also obviously we couldn't have living bacteria inside a gallery. So our invention was how to do that, see more and more that instead of just using kind of computer generating models, we'll be able to use biology in sensing, in studying, and understanding the world around us. So this is kind of the goal of this exhibit. It's to show that this is possible.
Bacterial computation. Amazing.
Hi, Maria. Do you all the or most of the projects that you have are really projections, like I don't know, 50 or 100 years from now? Many of them might seem utopian, even though they are not, or even we need utopia to move forward. Do you have, or are you working on some projects? I'm more interested in the urban ones, like you and Mitch were trained as urban designers too, that have phases, like so that, for example, I was very interested in the Navy Yards where you were like using ships to work on that. Do you have other projects, maybe of smaller scales, that can start teaching, for example, the citizens of Brooklyn of your examples, so that it's not just a projection in 150 years, but it's more like a progress for 3 or 5 years?
Thank you. So I think a lot of our projects, we're using what we call the kind of two-prong approach. I mean, one, it's kind of the big vision and the polemics, and then big models to illustrate that. But then it's backed up by some really serious research. And let's say with the mycelium project, we can do that today. I mean, Ecovative, it's a company that it's growing it for certain purposes, and we are building on their invention and expertise to just develop it to for other uses. So this baby seed, we can grow that today, and we actually are talking to several places, and they wanted us to make a big chaise lounge out of mycelium. So it's an actual material that it's being used today, and the same go to making a brick out of waste. We know we're not going to make a 54-story tower, but we can make one building block. And then what we have developed, it's this idea that they're puzzle fitted and pinned together, so this block can withstand lateral forces. So we really would like to take that technology to the developing world, where building materials are both expensive and scarce, and then teach them how to make these bricks out of garbage. So, and then also, so these are technologies that are applicable today. And our role as open network ecology is to really pass it on and have other people continue to work on them and bring them to market. But also what we have achieved over the years is, you know, from somebody who was kind of came from so much as an outsider and utopian vision. Now we are on the table. We are part of a lot of committees. We're invited by the city of New York, by the state. So they want to now listen to us. So I think that's kind of probably one of the most important achievement that we have. It's that we convince people that this is valid, and you need to start thinking today if you want to project in the future and have this technology be developed.
Well, I think that's a great point to end on. We invite you to join us. Maybe Maria will also join us if you have one more question you want to get to her, but please join us here for some drinks. And again, thank you very much, Maria.